cheers. Right. Sorry about that. I'm on my own today, so I'm running around. Laptop visualizer. There you go. So the podcast one's on the laptop.
Okay.
Yeah.
Thank you, sir.
All right.
Thank you.
No, because it's two different visualizers, you need one to So the one we put in is on the laptop input and the other one is on the yeah. Alright.
Guys, could you do question 1, please?
What is the power?
The power is defined as the rejection. The topology of projecting at 0 given the volume of P.
Yeah.
That's what we asked.
So we're looking for probability
Yeah.
of greater than or more, or what less?
Or less than 1.
Or less.
One or less.
Given
the volume of P.
okay.
Given the volume of P.
Yeah, so when we work with Untitled Chapter, go out and work how each of them each P.
Yeah, well, you don't need to do that now, but I mean, if you're asked in the exam, you need to do it, right?
Yeah.
But yeah, obviously you need a calculator. I don't have one, but you need a calculator to do that, yeah.
Yeah.
But don't waste your time doing that. Just go to, if you're done question 1, go to question 2. So let me show you guys how to do. Right, and this, okay, you're trying to test this versus this, and P is the proportion of defectives, and Y denotes the number of defectives in a
in a bag of 20. Now you are told that we reject H0, we reject the null hypothesis if y is greater than or equal to 7 or y is less than or equal to 1. This is the rule that is given, all right? And you are asked to find the power function. Remember, the power function is defined as the probability of rejecting the null hypothesis given the value for p. So this would be the probability that y is greater than or equal to 7 or y is less than or equal to 1 given the value for p. Yes? Now, in this case, it would be wiser if you use the complement rule. You guys know the complement rule for probability. There are probability, which says that this probability is 1 minus the complement of this event, which is what the complement of this event is that y is between 2 and 6. Yeah. Okay, guys. So now, if y is between 2 and 6, the possible values you can take are 2, 3, 4, 5, and 6. So it will be the sum of the probabilities that y equal to I for I from 2 to 6. Okay, now you must realize that the variable y represents the number of defectives in a bag of 20. So the distribution of y will be what? Will be binomial, exactly. So it will be binomial with parameters 20 and p. Okay, so this will be 1 minus you guys know the probability mass function for the binomial. I'm sure all of you know that. This what I have written here is the PMF of the binomial distribution. So this is the this is the power function for p, right? That's what you are asked to find. Now you are also asked to find pi of p when p is 0, 0.2, 0.4, 0.6, 0.8, and 1. So what you need to, I'm not going to do this here right now because it will be very time consuming and I will need a calculator. What you need to do is just sub in these values into this formula and work out the pi of p, right? Obviously you will need a calculator or computer to do that. Okay? And you are also asked to find the significance level. Remember, guys, I mentioned I talked about significance level in the lectures. It's the same as what? It's the same as, if you remember, I mentioned this in the lectures, the significance level is the same as the probability of type 1 error, right? Which is the probability of rejecting H0 when H0 is true, which is p equal to 0.2. Yeah? And therefore this is equal to pi at 0.2. So the significance level is the value of the power function at 0.2. Is that clear, guys, or not? Yeah. Does it make sense, guys? Yeah. Don't you feel lost? I don't know. Are you guys okay with this or not? Yeah. Yeah. Are you okay with that?
2, please, if you're okay with that. What is it? You okay?
Right. That means we are doing question 2 now.
All right, sure.
Question 2. that's okay.
Are you guys doing?
You got a question too? Alright guys, I know some of you have already done question 2, but if you haven't done question 2, let me show you. I think this is what you're given, okay? This is null hypothesis, the alternative, the rejection rule, and x is a geometric variable. And you're asked to find alpha and beta. Remember, alpha is the type 1 probability of type 1 error, and beta is the probability of type 2 error. So this is the probability that we reject the null hypothesis when it is true. Alright, so in other words, the probability that x is less than or equal to 5 when p is 0.1. Now, if x is less than or equal to 5, we can take the values 1, 2, 3, 4, or 5. Because remember, the geometric variable is only defined from 1 to infinity, okay? So this is the sum from 1 to 5 of the probability that x equal to I and this becomes, I'm sure you know, I'm sure we did this in week 1, guys. This, what I have written here, is the probability mass function, or the PMF of the geometric variable, right? So, I mean, obviously, if you have a calculator, you can simplify this, right? And beta is the probability of type 2 error, which is the probability of accepting the null hypothesis when h1 is true, right? And this is, you can write this as by the complement rule, you can write this as the 1 minus the probability of rejecting the null hypothesis when this is the case, right? Or this is 1 minus the probability that x is less than or equal to 5 when p is 0.2. Okay, and by the same argument as before, this is 1 minus the sum of the probabilities I from 1 to 5 of 0.2 times 1 minus 0.2 to the power I minus 1. Well, guys, so it's not difficult, is it? I know many of you have already done this, so but this is how you will do it. Yeah. You good? Okay, guys.
you need to use the lecture notes for this. You need to use the notes. You need yes, this way. Yeah. The stuff we did this way on yours, we didn't this way. You don't have to stop it on here. Because you have mu equal to 0 and mu equal to 4, so it falls under this category. So the rejection rule is
But in previous stats courses, it's always been mu equals nil, mu does not equal mu is bigger than.
Yeah, that's what.
How do you do it with h1 equals 4?
No, in this case, 4 is greater than 0.
Yeah.
So it falls under this.
So it's just simply it's
Yeah.
not bigger than 0.
Yes, bigger than 0. Yeah. So you use this as the rejection.
Yeah.
For number 4, you have mu equal to 0 versus mu not equal to 0.
Yeah.
So you just use this one.
Yeah.
This one. And you guys do question 3, please, now, if you're okay with this. For question 3 and question 4, you need to use the lecture notes because the rejection rule for question 3 and the rejection rule for question 4 are in the stuff we covered this week on Tuesday and Wednesday. So you need to use the lecture notes for the handwritten notes. One of them, yeah. Right? So do question 3 and question 4.
We use the first one. It's not the same.
Yeah, there's something you need to think of, guys. Which, or you need to use one of either the first one or the second one. I think the second one is more appropriate because you should read question 3. It says mu equal to 0 versus mu equal to 4. So the second is more appropriate.
page 20. I don't think you're looking at it's on page 20. Yeah, that page. Yeah. Okay, guys, if you haven't done question 3, could you please listen? Right, you are testing for this versus this, right? And I ask you to look at the lecture notes. It gives you the rejection rule. Now, what does it say, guys? If you look at the lecture notes, this one here, because you are testing for mu equal to 0 versus mu equal to 4, this corresponds to the second category on page 20 of the lecture notes, right? Because under the alternative hypothesis, the value for mu is greater than the value for mu under the null hypothesis. 4 is greater than 0, right? So you will use the second, rejection rule on page 20, which says that root of n divided by sigma, which is 2, times x bar minus mu 0, which is 0, is greater than z alpha, which is 0.05. So this is the rule that you will use. I think this equation, if I remember correctly, guys, I think this is equation 95. Equation 95 in the lecture notes. Yeah. All right. So now what you're asked to find, guys, is the probability of type 2 error. Okay, which is the probability of accepting H0 when H1 is true. Right? Now this is the rule for rejecting the null hypothesis. So accepting will be the complement of this, right? So this will be, you will accept if root n by 2 times x bar is less than or equal to okay. Now to simplify this, guys, I'm going to use the standardization, right? You remember the standardization? I done that several times during the lectures and also during the example classes. The standardization is based on this following fact that that x bar has the normal distribution with parameters mu and sigma squared by n. I'm sure this is stuff we did in week 1 or week 2 of this course. Right now we are conditioning on the fact that the true value for mu is equal to 4. Right, so to standardize this, what we need to do therefore is to standardize this, we need to subtract the true value for mu, which is 4, and therefore we also need to add the same number. Okay. Do you guys understand why I'm doing this? Yeah, because I want to use the standardization based on this, guys. That's why I'm doing this, right? And then I'm going to take this number here to the right hand side. Okay, if I take this to the right hand side, you will get this. You see, because the 4, when you divide by 2, it becomes 2 root 10. So when you take it to the right hand side, it becomes minus 2 root 10. Right? Okay. Now this guy here, because of the condition that mu equal to 4, that the true value of mu is equal to 4, this will have the standard normal distribution. Right? Okay. So therefore, okay. Now you see that from this step to this step I have dropped the conditioning, because the conditioning has been used to argue that this has a standard normal, and therefore we don't need that anymore. Okay, so that's why I dropped it. Okay, now this is equal to phi of phi okay, so that's the so this is the expression for the type 2 error probability, or beta. Yeah? Is that clear, guys? Okay. Can you do question 4, please, now? Question 4, which is similar to this. All right, guys. In this case, what would be the rejection rule? I mean, here you are testing for me equal to 0 versus not equal to. So the rejection rule would be. I mean, it's kind of. If you look at the lecture notes, it's kind of obvious. Which, all right, it'll be. Yeah, it will be this one, right? Okay, it is mainly. This is equation. Equation 92, right? In the notes. So I think what you're asked to find is the power function. Now remember, the definition of power function is the probability of rejecting the null hypothesis when the given value is mu. I think a lot of people get confused. The mu here is an arbitrary value, right? It's not any. It doesn't take any fixed value. It's an arbitrary mu. It doesn't take 0 or 4 or any other number like that. It's an arbitrary value, right? It can take any number from minus to plus infinity. All right. So you shouldn't consider this as taking a fixed value, right? Okay. That's a lot of people get confused about this. Right, I just want to say that. Okay, it's just mu, right? Now, the first thing you must do here is to get rid of the absolute sign, right? And I think I told you how to do that. To get rid of the absolute sign, you just say right? You say like this, right? Either this is greater than this or less than minus of it, right? Now the next thing to do is in order to use the standardization, you must subtract mu from x bar, right? So to do that, I'm going to subtract a mu from x bar, right? And because I have done this, I need to add also, right? Okay. All right, guys. I mean, the reason I'm doing this, guys, is because I want to use I want to standardize x bar. Remember, x bar has a normal distribution with parameters mu and sigma squared by n, right? All right. The next thing to do is to take this guy to the right hand side and this guy to the right hand side, right? Okay, and so that will give you okay. All right, guys. Now because of the conditioning, because of the fact that we are conditioning on the fact that the true population mean is mu, this guy here and this guy here must have this standard normal distribution. So is either n01 is greater than or n01 is less than Okay. Right, now these two events are mutually exclusive, they can't happen together, right? And therefore you can write it as a sum of two probabilities. First, okay. And finally, if you want, I mean, you don't have to do, I mean, it's okay if you leave it like this, you still get full mark, but if you want to express it in terms of phi or phi, you can do that. So this will be 1 minus phi at this, and this will be phi at okay. So this is the final answer, guys. This is the power function at mu. Are you guys okay or not? Right, guys? So it's I think after doing a few examples like this, you will get bored of it. I mean, you should get bored, after a while, because it's the same trick every example. It's just trying to standardize so that you use a certain distribution. Right. Okay, guys, can you do the next one? I know we only have a couple of minutes left, but can you do question 5 too? I'll give you a hint on how to start question 5, guys. To do question 5, what you must realize is that it's asking for the probability that you reject H0 given that mu is equal to 95 to be at least 0.9. This is what the question is asking you. The probability that you reject the null hypothesis given this is 95 should be at least. And this is the same as saying, because you are testing mu equal to 100 versus mu less than 100, this is the same as saying the probability that root of n by root of 20 is the variance, times x bar minus 100 less than or equal to minus z alpha is. It doesn't say what alpha, does it say what alpha is? Alpha is 0.5, yeah, it's 0.05, yeah, given mu is 95 to be greater than or equal to 0.9. Right, so what you need, the question is to find the value for n. So what you need to do is to solve this equation or solve this inequality for n. So the question is, what should n be, right? Okay, try to do that by yourself. I know I run out of time now, but try to solve this for n and see what you get. If you can't do it, just come and see me or send me an email. I mean, the solution is online anyway, so if you can't follow the solution, just see me or send me an email. Okay? All right, guys? Okay.
就是说不能打自己脸。我觉得复活节一定要这个课好好的所有的课都必须学。要让小朋友们也这个什么好玩就那个今天上课玩游戏的那个啊，会觉得他们怀疑自己的人生。多带的吧。然后算了，这个时间我再管一下。你俩你问到现在。怀疑人生，我他妈才叫怀疑人生。你们那个商量出来是什么？不是这样的，是这样的，是吗？我以为。